Guten Morgen, good morning, and welcome to Cisco Live. This is BRK SDN 4005, CCIE Skill Transformation to SDN Kungfu Master. My name is Himawan. I work for Cisco as Solution Architect. I've been in Cisco for about 10 years now. Total experience in industry is more than 16 years. However, the past 2 years has been very exciting since I started working with SDN and NFV. Let me ask question first. How many CCIEs in the room? If you are CCIEs, raise your hand. Oh, wow, it's like 80% of you. Okay, great. Did you know that there are only 40% CCIEs believe that they can work with SDN and NFV projects? That's why we have this session, isn't it? The number was taken from my personal survey early this month. More than verified 200 CCIEs participated in the survey, and they come all over the world, right? We will see more about the survey result later on. Have you seen this? As I speak explaining the slide for the next 60 seconds, there are so many things happening on the internet. More than 300 hours videos get uploaded to YouTube. So many people are making Skype calls, millions of likes on Facebook and Instagram. Many people are playing videos on Vine and on Netflix. As of 2015, we have about 3.2 billion people as the internet population. So, Mark Anderson, a famous venture capitalist from Silicon Valley, wrote this article 5 years ago for Wall Street Journal that software is eating the world, to highlight how software companies like Amazon, Netflix, Airbnb, Uber, they can create services that challenge the traditional business model. And if you see all of them, they have one thing in common. They don't need to build network infrastructure to connect to the end customers. Yeah, sure, Amazon built many data centers, but as customers, we can connect and consume their services using public internet infrastructure, right? And some of them really put pressure to the internet bandwidth. The one that has video contents, for example, like Netflix or YouTube. So it's great to be in IT business, isn't it? And it's great to be in network business as well, because now software is eating the network too. We see more and more software technologies get pushed into the network infrastructure. However, not everybody is happy. These software companies that now we call over the top, they put pressure into internet bandwidth, so the service provider need to keep upgrading their bandwidth, but they have challenges to monetize this internet growth, so their operational costs keep increasing while their revenue growth remains stable. And that's a simple math, right? When you have your costs keep growing up, while your revenue is stable, then your profit will go down. So those are the challenge for any CXO today. With all the competition, big data, mobile commerce, Internet of Things, there are top 3 questions that any CXO have in mind today. 1, how to increase the revenue. 2, how to reduce the operational cost. And 3, how to be faster. Faster to market, faster to deliver services, faster to recognize the revenue, faster to get the revenue. The past few years, we heard this software-defined networking topics popping up in many news headlines. And one of the promises from SDN is it can provide answers to those 3 questions. So is it true that SDN is no longer hype in networking? Is it true that SDN is our savior? When we try to find the definition of SDN, it seems like everybody comes up with his own definition, right? Many providers, many vendors, they provide their own perspective of SDN, they provide their own solution of SDN. And this adds confusion to anyone who wants to jump into SDN ship today. For business leader, they ask questions, so which SDN solution to go? And how to be successful? For us, the engineers, the technical communities, the question is, which SDN skills to be developed and how to develop those skills? I hope after today's session, those 2 questions will be answered. So we're gonna discuss this today, starting from the SDN and NFV market to see if the market is real. Then this is a general session in Cisco Live, so I don't expect a deep technical discussion. However, I still need to ensure that anyone who comes to this session, even without technical background, can catch at least the lingo of SDN and NFV, so we'll go through it very briefly. Then we're gonna discuss about the survey result. Where are the CCIEs today? And do they speak SDN? The next 2 sections are important for us to understand what kind of SDN skills we need to develop, how we provision the network in 2016, and how service provider buy the network infrastructure today. Then we're gonna have a special session about all-in-one VM. This is a virtual machine that you can run at your home, on your laptop, on your PC, to learn SDN NFV skill. And we're gonna close down the session with skill development planning. Okay, whenever we have new technologies coming to the market, who do we call to provide the market analysis? Who do we call to provide the magic quadrant? Gartner, right? Always call Gartner. But they don't release any SDN or NFV magic quadrant. Because according to Gartner, if it's open flow switch or data center switch that run VXLAN, for example, that is still considered data center switch. So go look at the magic quadrant for data center switch. But at least Gartner said SDN is moving already from the peak of the hype cycle towards reality. If it's in 2013, they said, yeah, SDN was at the peak. Everybody said white boxes will rule the world, right? We all CCIE will lose our job. There is no job. That was in 2013. Everybody will use open flow. In July 2015, Gartner said, hey, you know what? Now it's becoming real. Now we know that, yeah, there will be white box player, but at the same time, there will be traditional network still. There will be a hybrid approach, and SDN is not only open flow. It will be based on specific requirements, is use case driven. But we still need to know if the market is real and how big is the market. So the good thing is we have this SDX Central that has been following SDN and NFV development very actively, right? And they provide this number. If we look at the total addressable market of networking industry, which is close to $100 billion in 2015, growing to in 2020 is growing to $130 billion. By 2020, about 80% of network purchase will be influenced by SDX networks. That's quite a big number. Then SDX Central said, there are 6 major use cases in SDN. One is the network access control. This is how you program the access policy, the BYOD. And then there is a network virtualization, data center virtualization. And then there is a virtual customer edge, the virtual CPE use case. The dynamic interconnections, that's more like the SDN WAN. Then the virtual core and aggregation for mobility providers. And the data center optimization for big data and flow optimization. So With these 6 use cases, if we look at the total spending of 3 type of customers, cloud, enterprise, and telco, by 2020, that will reach more than $100 billion. These are the distribution of those 6 use cases. And we can see the biggest chunk are still the network virtualization, the virtual customer edge, and the virtualization for mobility provider. So the market is real, right? It looks real to me. What do you think? Okay. So now, let's look at the SDN and NFV very brief. I'm sure you have heard the story, how SDN was started, right? Have you heard the story about it? Like Stanford is the birthplace of SDN. They created Clean Slate project. Then they also created the E10 project, and one PhD student called Martin Casado, him and several other guys, they created OpenFlow. And then Martin with Nick from Stanford and Scott from UC Berkeley, they co-founded Nicira that was acquired by VMware in 2012. This Nicira acquisition was considered one of the first market validation that SDN market is real. There are some other names that are not shown here. For example, Guido Appenzeller. He was the co-founder of Big Switch Network. He was also helping with the OpenFlow inception. So if it's in traditional network device, we have both control plane and data plane in the same device. So control plane to run control function like routing, while the data plane to run the forwarding function, so to forward the packet from one physical port to the other. With SDN, we separate the control plane from the data plane. We put it outside the device. We put it in the controller. And that's the idea of OpenFlow. So we have OpenFlow controllers. Consider it as a software running on x86 server, doing the control function, calculating the forwarding information and so on. Then the network device now become much simpler. We need to install the OpenFlow agent on every network device, so the OpenFlow controller can communicate with the OpenFlow agent using the OpenFlow protocol to provide the information. Then the device will know what to do when it receives the packet in one port. The information gets downloaded from the OpenFlow controller. And this controller provides the API, application programming interface. So if you are a developer of network application, now you can develop an application by consuming the API provided by the OpenFlow controller. You don't need to know exactly how the actual network devices work. The OpenFlow controller provides this abstraction layer. The OpenFlow gets standardized by Open Networking Foundation, ONF, starting from version 1.2 and above. ONF was created by large service provider and enterprise like DT, Facebook, Google, and they are still serving as board member in ONF today. However, if you look at the member of ONF, you will feel pretty much everybody, right? So everybody seems to jump into this ship now. So okay, we have this OpenFlow protocol, and it has been standardized by ONF. But how about the controller? There are several open source controllers available, like Nox, Pox, Floodlight, Ryu, Onos. But the most well-known today, based on the number of contributors, is Open Daylight. So Open Daylight now is part of Linux Foundation project, initiated by consortium of networking vendors like Cisco and the other big names in industry. It's a controller that come up with a built-in application. For example, it has already a software that can automatically detect OpenFlow-enabled device. It has this topology manager. It has already an application to calculate the port statistic, for example, right? But this is still the controller. And then, vendor like Cisco, for example, they take the source code of Open Daylight, because it's open source SDN controller. Anyone can take the source code, including Cisco, and then Cisco add more functionality and start maintaining the code by themselves. In software world, this is what we call forking. And then it's become a product. Cisco Open SDN controller. You can see the controller is in the middle. Cisco add more functionality, more features, and now the controller can communicate to the network devices. This is what we call southbound protocol. It's not only using OpenFlow. We have different options like OVSDB or NetConf, and the controller provide API to the application, what we call northbound API. So again, the controller become an abstraction layer. If you want to create a network application, you just need to interact with the controller. You don't need to connect directly to the actual device. And that is the power of SDN, right? Because we have this abstraction layer in between the application and actual network device. We can develop many more applications without any need to attach ourselves to the actual network device. We don't need to know how it works, how the forwarding works, and so on. It's not our job. We just create an application, consume the API provided by the controller, and let controller push the information down to the network device. That's the power of SDN. And we heard this OpenFlow protocol. It's not the only one now. You can see it. There are some other protocols were invented and part of SDN solution, filling up different functions in the solution. So it's important for us to understand the network programmability options, starting from the existing network device. This is the network device that we know. So our application, like network management system or network monitoring tools, connect to the network device using the CLI or the well-known protocol like SNMP NetFlow. That's traditional network device. And then we have this pre-SDN time, where many networking vendors start opening up their API. For example, Cisco Nexus platform, they provide NX API that you can access. So if you have an application right now, you can use this NX API to configure the device, for example, or to do something else. You don't need to connect through the CLI or the SNMP like before. You can directly access the NX API. Then comes the SDN, the pure SDN or open SDN, where we separate the control plane, put it in the controller communicate to the data plane using different protocol and provide the northbound API to the application. Then we also have hybrid SDN. The idea of hybrid SDN is, hey, the traditional network that you call it traditional, come on, it's still running in my network today, right? It's not traditional, it's current. Okay, that's exactly the point. Let's keep it run as is, just like today, right? Why? Because it works and is an output of innovation for more than 30 years. So you want to throw it away and shift it to this controller base? No. Let's keep it running as is. Then we can introduce the controller, and whenever you need to do the programmability, fine. Develop application, talk to the controller, and controller can talk to this traditional network device using different protocols. That's the hybrid SDN. And the last approach is overlay network. So it's basically keep the traditional network as is, but we can run virtual network, logical network on top of it, then do the programmability on the virtual network. So Martin Casado, the one who created OpenFlow, right? When he co-founded Nisira, he used this approach to put an overlay network and start doing the programmability on that overlay network instead of the physical. And overlay is not something new, right? We are very familiar with overlay network, overlay protocol. Who can give me one example of overlay network that we use to communicate, let's say, between one branch to the other branch? Yeah, MPLS, JRE tunnel, right? That's overlay network, because the idea of overlay, you have this physical topology, then you connect the logical network, you create your new topology, right, that detach from the physical topology. You can have it your own, so there's nothing new here. The protocols might be new. In the data center, you will hear new protocols called VXLAN or NVGRE, right? But the concept is not new. Now let's talk about NFV, Network Function Virtualization. Because usually people say, hey, it's SDN and NFV. It's SDN and NFV. Are they the same? No, they are not the same. In NFV, if in traditional device, you have a purposely built hardware running network operating system, Cisco iOS, iOS XR, for example. Then you run the application on top of this operating system. So let's say you run routing process in user space. Then this box become a router, right? This is the traditional network device. With NFV, Network Function Virtualization, we want to disaggregate between this network function from the underlying hardware. So we want to run network function like routing or firewalling or intrusion detection as a virtual machine on top of commodity hardware like x86 servers. And instead of running specific network operating system, we can run a cloud operating system. The main driver of NFV as of today is agility and speed. People used to say, yeah, it can reduce the cost. I don't think so. Guess what? Because before you have to pay for purposely built hardware. Now, yes, it's commodity hardware, it's x86 servers, but now vendors start selling the virtual network function license. You can buy virtual router with certain license. So you just move the cost from the hardware into the virtual network function license, the virtual router license, the virtual firewall license, right? So the main driver today for NFV is agility and speed. Imagine if you can turn on and turn off virtual network function as you wish. It's very elastic, right? And you can connect one VNF to the other. Imagine you have virtual router, then you connect them to the virtual firewall, then you connect them to virtual intrusion detection. This is what we call service chaining. Before we have to do it with cable patching. Now, it's all logical links. So, not everything makes sense to be virtualized, right? If what you are looking for is pure performance, right? I just need the muscle, then okay, fine. Why don't you run it in specially or purposely built hardware? Because that's what it's good at, right? However, there are many other functions, layer 4, layer 7, that doesn't really require performance, but they exchange this performance with flexibility, with the elasticity, with the speed and agility of having VNF connecting to each other and making a service chain. In NFV, we have the reference architecture created by ETSI, European Telecommunication Standard Institution. It's a European institution, but this architecture has been adopted worldwide. So ETSI said, okay, there is a building block of VNF. That's where the virtual network function is, like virtual router, virtual firewall. Then we have this NFVI, Network Function Virtualization Infrastructure. That's where we have the physical compute, physical network, physical storage. Then at the virtualization layer, so we have virtual network, virtual compute, virtual storage, NFVI. On the right, we have the MENO, Management and Orchestration block, where we have Virtual Infrastructure Manager to manage the NFVI. We have the VNF Manager to manage the VNF, acting like the manager for the VNF to decide when to bring up virtual network function, where to bring it down, or scale up, scale down. And we also have orchestrator to orchestrate the whole solution. Then we can have service template and connector to OSS and BSS for management and billing. let's map directly sample products into ETSI NFV reference architecture, starting from the VNF. That's like the Cisco CSR 1K, the virtual ASA, right? For the virtual network, we can either use the open source like Linux OVS, or Cisco has VTF, VPP, AVS. For the virtual infrastructure managers, we can use OpenStack or VMware vSphere. Mostly, they are used for virtual infrastructure manager for compute and storage, while for the network virtual infrastructure manager or network VIM, we can either use the open source controller like ODL, ONOS, or Cisco Epic controller, Cisco VTS controller. Then as a VNF manager, Cisco has a product called Cisco Elastic Controller. Then the orchestrator, Cisco has something called NSO, based on TLF NCS. If you look at this picture, where is the SDN in this picture? This part, right? If you see this red box, that's the virtual network, and you have the controllers that we call network VIM, if we refer to the ETSI NFV architecture. So the controller like ODL, ONOS, or Cisco Epic VTC can manage the virtual network and even the physical network in some case. Okay? According to ETSI, when we have this SDN, separation of control plane and data plane, when we have NFV running network function on commodity hardware, it should trigger open innovation, right? If we can orchestrate the automation and the provisioning of both physical and virtual resources, we can create new service innovation that usually take us months. Now we can do it in days. So that's the power of SDN and NFV with open innovation. Let's switch to OpenStack quickly. OpenStack is the cloud operating system to manage the network, the compute, the storage, and the virtualization, and is part of Infrastructure as a Service, IaaS, Cloud Computing Project. Just to refresh, if the most left is the private cloud, where you have to run everything by yourself. If you buy services from IaaS provider, they will take care of the servers, networking, storage, and virtualization layer, while you can focus on the upper layers, like the application, database, security. And that's where OpenStack come to play, right? So OpenStack was created by Rackspace and NASA, and it's basically a collection of open source projects. So we have a project called Nova, for example, to manage the compute services, Neutron to manage the network services, Keystone to manage the identity services, or Horizon is the dashboard for OpenStack that you can use to administer the OpenStack. Go back to the virtual network. So let's say you have a compute nodes where you install hypervisor, either Linux KVM or VMware EXI. And you connect those compute nodes, the servers, to the physical network, right? On top of the hypervisor, you run the virtual machine, and you have virtual switch, okay? The virtual switch can create an overlay network by using overlay protocol, such as VXLAN, okay? What VXLAN does basically is it encapsulates the whole layer 2 frame from one OpenV switch into IP protocol, UDP packet, and add the VXLAN ID. And it's one-to-one tunnel. That's overlay network, right? We have our own topology between OVS that is different with the physical topology. So why I'm bringing this up? Because OpenStack Neutron, the one project in OpenStack to manage the network, is used to manage that virtual network, to manage the OVS, for example. And that's the link between SDN and OpenStack. So if we look at the full stack of SDN and NFV solution, let's start from the bottom. That's the underlay technologies. That's the physical technologies, right?